Lastly, let's look at a situation where we have a current-controlled current source as well as a short. Say we're interested in determining VC, our node voltage, at node C. To begin, we'll employ our standard four-step procedure. Step 1 is to assign our nodes, which were already given as A, B, and C, where D is ground, and our line currents. I1 runs through a 10 ohm resistor, which exists between nodes A and B, and I2 runs through a 20 ohm resistor, which exists between nodes B and C. Step 2 is to assign our voltage potentials consistent with our passive sign convention. V1 corresponds to your 10 ohm resistor, where its polarity is dictated by the directionality of I1, and V2 corresponds to your 20 ohm resistor, where its polarity is dictated by the directionality of I2. We put a dashed box around nodes A and D, which constrain our independent 6 volt source. Step 3 is to determine or apply our proper number of KCL equations. We have 4 nodes, we have 1 voltage source, thus we need 2 KCL equations applied to our non-zero and non-specified nodes. Thus we'll apply our KCL equations at nodes B and C. Starting with node B, we recognize we have I1 entering and I2 and IA exiting. Thus we construct our KCL equation such that I1 is equal to IA plus I2. And then when we look at node C, we recognize that I2 enters node C and 5IA exits. That is, I2 is equal to 5IA. We can substitute our expression for I2 from our KCL equation at node C into our KCL expression at node B, such that I1 is equal to 6IA. Now step 4 is to apply Ohm's law in terms of our node voltages to our KCL equations. Starting at node B, we had I1 was equal to 6IA, such that I1 can be expressed as VA minus VB per 10 ohms, and this is equal to 6IA. Our KCL equation at node C stated that I2 was equal to 5IA, or we can express I2 as VB minus VC per 20 ohms, and this is equal to 5IA. We still need an additional equation within, and that comes from our voltage source. We know VA minus VD is going to be equal to 6 volts, where VD is equal to 0, thus VA is equal to 6 volts. And we have information about node B. Our voltage at node B is equal to that at node D, which is our ground, which is 0 volts, thus VB is equal to 0 volts. Substituting these known values into our KCL equations, starting at B, we have VA, which is 6 volts, less VB, which is 0 volts, per 10 ohms is equal to 6IA, or IA is equal to 1/10 of an amp. Now moving to our KCL equation, at node C, we would have VB, which is 0 volts, minus VC per 20 ohms is equal to 5IA, or VC is equal to minus 100 IA, or VC is equal to minus 10 volts.